All right, hello, and welcome to my series on programming in Brainfuck. I will include this link to this GitHub page in the description. Basically, this GitHub page will have a small description of the Brainfuck language, the project itself, and all the source code to all the Brainfuck programs, as well as the interpreter. So you can kind of build that project and hack away at these brainfuck files yourself. So just brief overview of the brainfuck language. Brainfuck is an esoteric programming language that really is meant to be simple and have a small compiler. That's why it was originally written. It consists of 8 rules. This right angle bracket will shift right to the next block of memory or a byte of memory. The left angle bracket will shift to the previous byte. Plus will increment the current byte of memory by 1. Minus will decrement it. A period will output the current byte of memory. A comma will assign that byte a byte of input to that current byte. And then we have our square braces, which will act as a sort of loop, which basically means if the current byte is not equal to 0, then it will continue executing whatever is inside these two braces. So I've included some resources here that you can check out. Both are great in understanding Brainfuck. The wiki is good, and it has a lot of excess information, and Brainfuck in 100 Seconds by Fireship on YouTube also does a really good job at condensing that information. So the real point of this is just for myself, really. I would just like to improve my understanding and problem-solving skills, and I would also just think it would be a lot of fun. So there is a small note here is that I don't know Brainfuck. This isn't something I've done much with. I've written an interpreter already, as well as a couple programs just to test it out. They work, but I'm not doing anything clever, at least not to begin with. I'll have to learn those tricks as I go. So earlier challenges might have less clean, more repetitive, less modular, if you can even consider it modular at all, code compared to my later challenges. So today we're going to go ahead and start off with the interpreter. And we're going to be writing the interpreter in C. I already have our file set up here. I have a few things I would like to accomplish in addition to the regular interpreter. I would also like to have an option for the type of output. That might be having a numeric option so I can see the actual numeric value of the byte or the character value of the byte. Both of these things would be really useful, especially when we're doing something more oriented towards, user-friendly output as opposed to numerical output. So let's go ahead and begin. The first thing, of course, what we want to do is make sure that we have the correct amount of arguments. We're going to start with just this for now and say so we need them to input a file, and so we'll go ahead and return our error code. Now we'll go ahead and get our file name. And we'll go ahead and try to open that file. So file pointer, and we'll say if so we'll go ahead and open the file, and we'll read it, and we will check if it's null. So one thing to note here is I am using C99 or C90. I don't typically code in C90. I usually do write C99 or C11 code. The only reason I'm using C90 today is just I'd like to get into that habit of writing more compiler independent code. So that's just something I'm going to be doing today. So bear with me if I have any compile time errors due to that. But we'll go ahead and handle line break. All right, so now we have our, we'll go ahead and close that. And let's go ahead and give that a shot. So let's build that, builds fine. And I then have, okay, that works, and then that also works, and then that works as well. Okay. So everything's working so far. This command that I did at first, this was a file that does exist. There's nothing in it. This is not a working brainfuck file yet, or this is not a full brainfuck file yet. It's an empty file, but we'll get to that eventually. But now that we have our file, let's go ahead and create our array of code, basically. So how this is going to work, and let's actually add in a new file, and we'll call this test.brainfuck. And I'm also going to add that to our gitignore. So this really is, we're just going to use this for just kind of seeing if we can extract the correct characters and ignore the comments, which in brainfuck, anything that is not a symbol that is recognized is just a comment. So we'll go ahead and try to build our array of code, and the way we'll do that is to create a pointer, or let's actually do size, and let's go to the end of the file, and then we'll set size equal to, and then we'll rewind our pointer. So now we're just getting the size of the file in bytes, and we'll go ahead and create a character array called code, and we'll actually call it use calc and do it like this, and we'll actually add one more to that size, so we can go to the end of it and add a null terminator. We want to use a null terminator for this code. For one, it will make it easier to actually iterate through it. We can just use a pointer, and also I would like to print it out and make sure that we have the correct make sure that we have the correct symbols within it, and the incorrect ones are stripped from it. So this should go ahead and create that array for us, and I want to do one more thing. I want to create a block of memory. Actually, we'll do that later. Let's go ahead and try to build this. So we have a small error here. Looks like I forgot to include standard library for memory. So we have that now. Now let's go ahead, try to build that again. It worked. So let's go ahead and start building this array. So we'll just go ahead and say we'll just call it C. We'll say for let's do a do while. So we'll go through the file here and say C equals f get C fp to get every single individual character. This shouldn't be a pointer. Now we'll say we'll probably have an index, and we'll go ahead and say, all right, so now if C, let's actually say, okay, index plus plus and code at index equals C. So if we take a look at this, we can now, and I think we'll have to do that. So now if we build that, let's go ahead and run it with the test. And there we go. So we have all our characters here. Looks like we actually have a Null Terminator problem there. So, okay, so the error was just taking this line of code, which was up here, and moving it down here, and that seemed to fix it. Not sure why that fixed it. I'm assuming because EOF was getting assigned to the end, and that was, of course, an invalid character, so that's likely what the issue was. So the next thing we're going to do is make sure that we have the right characters. So the way I'm going to do that is to create a small function, and we'll actually use std_bool for this, and we'll call this a Boolean returning function, and we'll call it valid, and it will take a character, and we'll call the valid array, or valid characters. We have the angle brackets, comma period, these, and the plus minus. And now we'll say, sorry about that. Now we'll say, okay, so for valid characters, no, we'll say sure, current, for current equals valid characters, current current does not equal the Null Terminator, and current plus plus, we will say if our C is equal to our current, we will return true. Otherwise, we will return false. Oh, whoops. Forgot it again. Like I said, programming a lot of C11. Okay. So now we will go ahead, and all we'll do really is put these following two lines in some brackets. And that will go ahead and fix our problem there. Now, what we will do is we want to resize this code. So we'll go ahead, and this is not the best practice, but we'll go ahead and do it anyways. Code, and we'll do index plus 2. And then we'll say code at index plus 1 is equal to this. And the reason we're doing index plus 2 is because index is offset by 0, so we of course want the size to be plus 1, so we can tack on this Null Terminator. So we have to add 2 here and then 1 here, and that will get us our code. So we'll go ahead and print that out one more time, close the file afterwards. So let's go ahead and run that. We have a small issue here that's in our valid functions. Let's go ahead up there and take a look. Looks like we just have a equal sign. Let's go ahead and build that, and let's run test.bf, and there we go. There's all our valid characters, and all the strings are stripped. So let's go a little bit further here. We'll go ahead and get rid of our debugging code. And now we will create our memory array. So our memory is just going to be an array, and we'll actually do a macro up here for our and it's 30,000 for Brainfuck, 30,000 bytes. So we'll go ahead and use that. and we'll initialize that to 0. So next, what we want to do is go through all of that code. So we'll go and we'll say for, we're actually going to have, well, we'll get to that later. For, sorry about that. For instruction equals code. And that's why we use the Null Terminator. And now we can continue with that. So we'll go ahead and make a switch statement for our instruction, and that it will be the end of our outline. So now it's time to implement our instructions. So let's go ahead and start with just the plus with the shifts. So this will take our we will also let's also do another so we'll also have a memory pointer, and this will be our at our memory. So we'll just say memory pointer plus plus, and then we will handle the left shift, which is just minus minus. And next we will work with our increments. And then our decrements. So there is our four more simple instructions. Now we want to work with our input and output, which are also pretty simple. So for now, we'll just output a character value for our output. Like I said, we're going to have an option eventually that will actually check if we want a character output or an integer output, but for now we're just going to work with the integer output. And we also don't want to use the new line here because we want the user to have control over that. So lastly, we will input a character, and we will use a integer here, and we will use that with this. So that should be everything. So what we're going to do now is kind of test out, it's not everything, sorry, we still have the square braces, but for now we're going to just test these out. So the way we're going to do that is we're going to take a number in, then shift right, then shift left, and then output that number. Well, let's add to it and then output it. Okay, and then maybe subtract twice. Yeah, let's try that. So we'll try, let's say 42. We'll try 42. So if I want to print out 42, which is a asterisk, these two don't really matter, but 42 I would input 43, because then we would get 44, subtract twice, then output the star. So let's go ahead and try that. Well, first we have to build it, and we'll probably get something here. Looks like it's just this instruction, and if we try that again, we'll get this warning, but that's mostly just because we can't really get anything out of this, but we'll take what we can for now. So let's go ahead and try it, and So what did I say? 43. This should give us a star. There it is. So far the instructions work correctly. Now we're going to introduce our square braces. Now these are a little tricky. I've already racked my brain over this earlier, so we'll go ahead and go through that really quickly. Let me just type our little outline here. So the way we want to do this is we're going to use a two integers called open loop and a close loop, which are both 0. And when we have a open bracket, we are going to check if we have an empty value at our current memory pointer. And if that's the case, we want to set our open loop to 1. And if that happens, it will trigger this while loop that will say, okay, if our while that's happening, let's go ahead and take our instruction and shift it forward. And the reason we're doing this is because if we have an open loop, we want our instruction to go all the way to the end if we don't have anything at that memory pointer. So if it's 0, we're going to skip to the end of that loop. So this is what that's going to do. This is a really inefficient way of doing things, but the other way would be to use a sort of map to map each opening bracket to the closing bracket. And that that data structure would be much more efficient, it would also just kind of be a little too complex for the sake of what we're doing here. So now what we're going to do is check the instruction for any additional braces. So if that's the case, we will increment our open loop. Otherwise, if it is a closing brace, also that would cause us problems. We will go open loop minus minus if we have a closing brace. So next, we will go to our closing bracket, and this will actually be pretty much the same thing. We will accept of a few key differences. If we have a value at our memory pointer, then our close loop will be equal to 1. And this is different because this is checking if we have a value. And the reason we're doing this is if we get to that end of the loop and we have a value in that current byte, we have to do the opposite from what we did here. We're going to backtrack all the way to that opening loop. So we'll do while close loop. We'll decrement our instruction, check our instruction. We'll do the same thing here as we did there. And check that pointer again for another closing bracket. So there is our loops. Sorry once again, I'm very sick. And I'm not really planning on editing this video too much. So the coughing, I'm really sorry about that, but I don't really have the time to edit these videos right now. Hopefully I can come back and cut these coughs out. But for now, just bear with me if you can. So there's our loop. And let's go ahead and we'll test this one by actually adding two numbers. And that's a interesting little trick. Don't worry about it too much right now because we're actually going to go into that a little more in depth later on. But for now, we're going to take an input, take a second input, then we're going to shift back. We are going to say, okay, while we're here, Let's go to the next one, then decrement. Then we will shift back out and output what we have. So this will add two numbers and then output the result. What I'm going to do is try to get the star again, so 40 plus 2 essentially. Let's go ahead and build that. We have a couple errors here. Just looks like we have a missing if. And where was that? Right here. So make sure you actually write your instructions. Whoops, took a screenshot. Let's go ahead and build that again. Same problem, else if. Okay, we have a issue here. Also, please try to ignore the snoring dog. I don't know if you can hear that, but I have a very loud snoring bulldog in the background, so please ignore that if you wouldn't mind. And let's go ahead and run it. So 40 and 2, and we get a star. So our loop works, and that means our interpreter is almost done. We may want to add a few command line options, like I said. Also, I do want to see what this warning is suggesting. If we can do that 40 plus 2, it still works, and it gets rid of that warning, so we'll go ahead and keep that. So the last thing we're going to do, well, not the last thing, we're going to see if we have time for our runtime errors, but let's include some options. So we'll go ahead and say, okay, so we are definitely going to arg c-1. That will get us our file name, and less than 2, or arg c is greater than 3. So this will just kind of, we'll say output option. So we'll go ahead and check. We're just going to have one output option, and that's going to be the integer output. So we'll go ahead and have a flag here that is our integer option. That's, of course, false to begin with. And we'll say, okay, so for, C90 int I. For I equals 0, I is less than arg c, I plus plus. Let's actually start this at 1. And we'll say if arg v at I, and we'll actually have to say, okay, let's include our string here. And we'll compare it, and like I said, this isn't anything special, so we're not going to worry about memory safety right now. If not, with, and we'll say, what do we want, dash n for numerical. Then we'll set our integer option equals true. So that will give us our integer option. So we'll just go down here and say, okay, if integer option printf, this same thing essentially, except with that, and then else. Okay, so let's go ahead and build that and run it with dash n and 42 and 42. There we go. So there's our integer option. Now let's just add a couple runtime errors. The only real one we need is a out of bounds of memory. That would help. But now that I think about it, we would just get a seg fault for that. we would just get a seg fault if we went out of bounds. And we'd have an infinite loop, and we definitely see that. So we'll just kind of leave runtime errors out for now, and maybe we'll have a video where we come back to this and add those if it comes to that point. So for now, let's just accept what we have, because this is actually a pretty good little interpreter. So now I guess the only thing we'd really want to do is use is to create our first brainfuck program. And so let's go ahead and use hello world, and let's write hello world. So what we want to do here is get an ASCII chart, and they have a great one at cplusreference.com. So we'll go ahead and look at what we need. So if we start at our characters here, we'll do it in all caps, and we'll make it really simple. Let's start with H, and we'll kind of go from there. So it looks like everything is going to be at least somewhere past around the 70s. So yes, everything is in the 70s for hello. So we'll go ahead and do that. So how we want to do this is increment our first block by 7, and then we'll go into a loop and increment our second. We'll shift over to the second block and increment by 10, and then we'll go back and subtract. And now we'll go ahead and accept this for now. So we'll just say, okay, for H is 72, so we'll go ahead and shift that. Then we will see E is 69, nice, so 1, 2, 3. Then we have L, which is 76, so 1, 2, 3, 4, 5, 6, 7 output. And there's 2 of those, so might as well. And then our O is 79. Okay. And next is world, which is a little more difficult because we have we're in the 80s here, so we'll go ahead and shift over, and we'll start with 80. So we'll start there, and then we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and subtract, and then we'll go over and output that. Let's see, so world W is, we'll actually do one more then, and we'll subtract 90, or 3 from 90. We also want to get a space in there, which is just 32, so we'll go ahead and 32, I believe I said, so we'll go ahead and do that. Then we'll shift over and start world. So let's go ahead and see O. O is 79, and this is 87. So we'll go ahead and shift over again. 89, I think I said, or 79. Okay. And 79. Yes, 79, so let me just do that. And then WO. R is 82. So we're at 79, so we'll just do that. L is at 76. So I'll put that. And then D is 68. So we'll go ahead and do that. So we're just essentially incrementing to each number, and if this doesn't make sense to you, we are shifting over a, let me just see here, D is 68, so we're incrementing our value, so in this case, up to 7, and then we're shifting over and adding 10 to the next one each time for each of these. So this will tick down at 10, 20, 30, 40, 50, 60, 70, and then subtract 2 from that. We might as well shift over. And so now that will get us to our 68. So this, lastly, we're going to use our line break, which is this, or line feed, which is just 10. So we'll just do that and shift it over. We'll be consistent and add the shift at the end of this line. So as long as I didn't mess that up, we should get a oh, let's get rid of our numerical. Hello, oh boy. Okay, looks like we forgot some shifts here. So this space doesn't seem to be working. So space is 32. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 2. Okay. 1, 2, 3. Looks like we have a small issue. Oh, yep, there it is. Now let's try that. Hello. Oh, we're getting better. Okay. This and oh, come on now. So this is we're not even have the right amount of letters there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we go by 10 here. Let's make sure that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we're going 90, so 87. Oh, and you know what? We have an extra. Okay, getting there. And then this one. So this is R, which R is just 89. That shouldn't be right. Why would I do that? 82. Okay. That's why we have, so this is 89, and this is 90 minus 1. Yeah, that'll do it. Let's get rid of that, and let's actually add 2 here, and then R, W, O. Oh, no, that's why I had it. Okay, yeah, no, that's right. Yeah, that should be O. Why is it not O? Because that's 90, and then we loop through, then we shift over and subtract 1. Ah, yes, because it is 79, now that I look at it, so just 1 plus. There we go. Then R is, of course, 82, which, I mean, that should, this gets us to 89, so that should get us R, and then I think world. There we go. So there's our Hello World program. So now we have a complete program in Brainfuck, and our interpreter is working. And just to make sure everything's good, let's go ahead and comment this out. Hello, space, world, and of course, our line break. Okay, so there is our first Hello World program, and I think we did a pretty good job, all things considered. So I will go ahead and add this to the GitHub page and upload this video to YouTube. Once again, if you've made it this far, thank you. I know it's a little bit of a rough recording. I haven't really gotten a feel for how I want to do these. I am a student, and I also work a job, so I don't really have a lot of time to edit these, and I hope you can understand that, and hopefully I do get the time to make these a little more high quality, but for now, this is what we're going to work with. So thank you for watching, and like I said, I'll have the links to the GitHub in the description, and feel free to leave any comments, criticism, or anything you'd like to see. Any brainfuck challenges. I'm sure someone has made some pretty crazy things, but keep in mind that I want to keep these videos short, at least as short as I can possibly make them. And the challenge is kind of simple. So anyways, thanks again, and have a good day.